Hello friends, welcome to the e-learning program of KT College Nasik. I am Dr. M.K. Deore. Today I am going to take the third lecture on chapter number 6, types of the lasers. Friends, on this chapter I have taken the two lectures, and in the previous lecture we have seen the different types of the lasers, that is the classification of the lasers, and the two types of the lasers, such as the solid state type laser, in which we have seen about the ruby laser, and the second type is the gas laser, in which we have seen about the helium neon laser. Friends, today I am going to take the third type of the laser, that is the semiconductor lasers. Friends, the semiconductor lasers play a very important role in our everyday life because there are the number of applications in which we are using the semiconductor type of the laser. The semiconductor lasers are also known as the laser diodes because the semiconductor laser is simply made from the diode, the PN junction diode, and due to that it is known as a laser diode. The semiconductor lasers are different from the solid state lasers. Now we have seen about the solid state type of the laser, in which we have seen in details about the ruby type of the laser, and these solid state lasers are different from the semiconductor lasers because in a solid state laser the light energy is used as a pumping source, whereas in a semiconductor laser the electrical energy is used as a pumping source. That means these are the basic difference in case of the semiconductor type of the laser and the solid state of the laser. A semiconductor type of the laser specially fabricated by using a PN junction diode, and this PN junction diode emits the laser light when it is working in a forward bias condition, which generates the highly intense coherent beam of the light. That means in a semiconductor diode laser, simply a PN junction diode is used, which is operated in a forward bias condition, and it generates the highly intense coherent beam of the light. The semiconductor diode lasers were developed by the Robert N. Hall in early 1960s and are also referred to as an injection laser also. In a semiconductor diode laser, a PN junction of the semiconductor diode forms the effective medium, which is also known as the laser medium, and the optical gain is produced within the semiconductor material. Friends, in a semiconductor diode laser, basically it is a PN junction diode, and the PN junction, which is made from the different types of the semiconducting material, which works as a active medium or the laser medium, and the optical gain is produced in that lasing medium. Now the principle on which the semiconductor laser diode works. Now see here, this is simply a PN junction. When a PN junction diode is forward biased, friends, you have already studied about the PN junction, how it works in 12th standard also and in T.Y.B.Sc also. When a PN junction diode is connected in a forward bias condition, we know that the N-type material contains the majority of the electrons and the P-type material contains the majority of the holes. And when this PN junction connected in a forward bias condition, the electrons from the N region and the holes from the P region crosses the junction and they recombine with each other. During the recombination process, the light radiation is released from a certain specified direct bandgap semiconductors like the gallium arsenide. Now see here in this second figure, we can see here, this is the figure of direct bandgap. Now here the material used the gallium arsenide, such a material having the direct bandgap and in which when the PN junction operated in a forward bias conditions, now that times the recombinations of the holes and the electron takes place and in such a direct bandgap material, during the recombination there is the emission of the photons. Now see here in this figure we can see here there is the emission of the photons and that emission of the photons radiates the light. And such a radiation of the light is known as the recombination radiation. The photons emitted during the recombination stimulates the other electrons and the holes to recombine and as a result the stimulated emission takes place which produces the laser. The friends, in a second chapter we have seen about, or in the first and the second chapter we have seen about the process of the stimulated emission and how the amplification takes place. Similarly, in case of the semiconductor diode also, there is also the process of the stimulated emission takes place and this stimulated process which result in the production of the laser beam. So this is a very simple principle is used in a semiconductor laser diode. Friends, we are going to see in details about the construction of a PN junction laser diode or simply the semiconductor laser diode. Now see here, this figure shows the basic construction of the semiconductor laser diode. I have already told you that a PN junction diode is used as an active medium. Now then, such a active medium, that is the PN junction, is made from the single crystal of gallium arsenide. Now initially, during the construction of a PN junction diode, now simply they use a single crystal of the gallium arsenide, that is the G.A.S.A. And these crystals were cut in the form of the chips. By using in these chips, the P and N regions are made from the same the crystal, that is the same the semiconductor material of the germanium and the arsenide. By heavily doped the arsenide into the gallium, which forms the N-type material, and whereas the P-type region is formed on the N-type by heavily doped the zinc atoms. So the friends, initially during the fabrication, the gallium arsenide cuts into a single crystal or cuts into the crystal which is looks like the simple chips, and by using these chips it forms the N-type material by heavily doped the arsenide into the gallium. So there is the formation of the N-type material. Now then, how the P-type material gets formed? For the formation of the P-type region or the P-type material, a heavily doping of the zinc atoms into the N-type crystal, there is the formation of the P-type region. So now see here, in this figure we can see this is the N-type region and this is the P-type region. Thus the chip consists of the two parts having the electron conductivity, that is the N-type, and the hole conductivity, the P-type. And when these two junctions forms, when there is the formation of the two regions, there is the formation of the PN junction. So see here, the N-type, the semiconductor with the sufficient number of the electrons, and the upper region is the P-type semiconductor with sufficient number of the holes. In another way we can say that the P-type regions or the semiconductor with insufficient number of the electrons, and in between this P region and the N region there is the formation of the PN junction, and this PN junction works as the active medium or the active layer. Now then see here, we have already seen that any laser having the three basic components. One is the active medium, the second one is the optical resonator, and third one is the pumping source. So by taking a suitable crystal of the gallium arsenide, there is the formation of a active medium. Then second one is the optical resonator. How the optical resonator creates in the PN type of the semiconductor diode. Now see here, the end faces of the junction diode are well polished, Now that means here the right face and the left face of this PN junction diode, PN junction material were well polished and parallel to each other. Now this is the one junction, this is the another junction. Now these both the junctions are parallel with each other and they were polished. These two polished surfaces acts as an optical resonator through which the emitted light comes out. Okay, that means here now this side acts as a 100% reflectivity, that is highly reflective end, and this end or this surface acts as a partial reflectivity, so it is known as the partial reflective end. And the top and the bottom face of the diode, which are parallel to the junction plane. So see here, this is the junction and this is the top and the bottom surface are parallel to this junction surface. These planes are metallized so as to take the external connections. So the upper and lower, that means the top and the bottom surface are metallized, means it having the metal contacts which are used for the external connections. The front and the back face are rough to suppress the oscillation in unwanted direction. Now see here, this is the front face and there is the back surface. So these two surfaces are very rough to surface, because here during the oscillations, when the photons will be during the spontaneous emission, when the photons are emitted in all direction, so here these two surfaces suppress the oscillations in unwanted direction. That means here they are moving, they should move parallel to the optic axis. The third one is the pumping source. Now in a semiconductor, the diode laser, a forward biasing is used as a pumping source. That means the PN junction diode should be operated in a forward bias conditions, and we need the external power supply. So here the external power supply connected to the PN junction diode works as a pumping source. The PN junction is made the forward bias, that the P side is connected to the positive terminal of the battery and N side is connected to the negative terminal of the battery. And under the influence of the forward bias electric field, now that means in the second figure we can see here, after connecting the battery to the P type and the N type, under the influence of the forward bias electric field, the conduction of the electrons will be injected from the N side into the junction area, while the holes will enter the junction from the P side. Now see here in this figure we can see here the P type N type material contains the majority of the electrons. So under the influence of the battery supply, now the electrons will be moved towards the P type materials. Now that means they are injected from the inside into the junction. Similarly, the holes will enter into the junctions from the P side. Thus, there will again the recombination of the holes and the electrons in this depletion region takes place, and if we increase the forward bias voltage across this PN junction diode, the depletion layer becomes thinner. So in the following figure we can see here, this is the energy level diagram. Okay, now here we have seen the conduction band and the valence bands. So in this energy level diagram, this is the energy level diagram of the semiconductor. And when the p-n junction diode is in a forward bias condition with a large applied voltage, the electrons and the holes are injected into the region in a considerable concentration. Now here, the region around the junction contains the large amount of the electrons in the conduction band and the large amount of the holes in the valence band. So in this energy level diagram, we can see here. Now there are the large number of the free electrons in the conduction band, whereas the large number of the free holes in the valence band. If the population density is very high, a condition of the population inversion is achieved and the electrons and the holes recombine with each other, and this recombination produces the radiation in the form of light. So similar to the solid and the gaseous type of the laser, by using the suitable voltage across the p-n junction diode. So we can see here, this is the excited energy level and this is the ground state energy level. That means you can say that the conduction band works as a metastable state and the valency band works as an ground state. So across this conduction band and the valence band, there is the formation of the population inversion, and during the recombination of the electrons and the holes in such a type of that the material such as the gallium arsenide, it emits the photons, and these photons emits the laser lights. So the photon emission is stimulated in a very thin layer of the p-n junction, which is in few micron. So here in this energy level diagram, we can say that when there is the recombination of the electrons and holes takes place within the depletion region, that times it emits the photons, and these emitted photons produces a light source, and that light or the beam of that the light is nothing but the laser light. When a forward bias voltage is increased, more and the more light photons are emitted. So now see here, we can see here, that means the amplification will start, and due to that the more light photons are emitted and the light production instantly becomes stronger. Thus the photons will trigger a chain of the stimulated recombination, resulting in the release of the photons in a phase. So here as we increase the forward voltage, now then the stimulation process will also increases, and the large number of the recombination takes place, and due to this large number of the recombinations, now large number of the photons will be getting emitted. So now in this optical resonator, what will happen here? These number of the photons are moving parallel to the optic axis, and in this way there is the amplification, and finally these photons will be get emitted from the falsely reflective ends, and so in this way there is the formation of a beam of the laser light. The photons moving, now see here, the photons moving at the plane of the junction travels back and forth by the reflection between the two sides placed parallel and opposite to the each other, which grows in the strength of the amplification. After gaining the enough strength, it gives out the laser beam of the wavelength 8400 angstrom. So now in this way, here we can see here that large number of the photons will be moving in between these two ends of the reflecting ends. So this is the highly reflecting end, this is the partially reflecting end here. So when the stimulation process increases, the amplification will be increases here, and after the sufficient amplification, that means beyond the threshold amplification, it emits the laser beam having the wavelength 8400 angstrom. Now see here, the wavelength of the laser light is given by, we know that the difference between the two energy levels, that is E2 minus E1, it is equal to be the h nu, and the difference between these two energy levels E2 minus E1, we can show it by using the EZ, that is the band gap energy. By substituting the value of the nu, then we get that EZ, it is equal to be the h into c divided by the lambda. Therefore, from this we can calculate the wavelength. That is, out the we can if we know the wavelength, then we can calculate the band gap, or if we know the band gap of that the particular material, then we can calculate the wavelength. And so here the lambda, it is equal to be the hc divided by the eg. So remember here the eg is the band gap energy. So the friends, now in this way the laser diode works and it emits the beam of the radiation having the wavelength 8400 angstrom unit. So the friends, if you have to first know about how the semiconductor diodes work in a forward bias condition, then you can easily understand the working of a semiconductor laser diode. Now then we are going to see the different advantages of the semiconductor diode laser. The semiconductor diode laser is not suited for the many applications due to its low power production. The second advantage is that the semiconductor diode laser, which is in very small in the size, that means its dimension is very small, and also the arrangement is very simple and compact. The semiconductor diode laser is very efficient. The laser output can be easily increased by controlling the junction current. While operating the semiconductor diode laser, if we increase the strength of the forward voltage, so what will happen there? We can easily control the junction current here. So the junction current, we know that the junction current is depends upon the applied forward voltage. Therefore, by controlling the forward voltage, we can easily control the junction current. The next advantage is that it is operated with the low power as compared to the Ruby and the CO2 laser. So here, for the operation of the PN junction diode, that means the forward, during the forward biasing, we need the very small voltage. The next advantage is that it requires a very little auxiliary equipments. So we need only the simple power supply. The next is that it can have the continuous wave output or the pulse output also. So both types of the output we get from the laser diode. That is the wave output also and the pulse output also. Due to that, the semiconductor lasers are very cheap, economical, and affordable. So the semiconductor diode laser nowadays is very popular because due to these all advantages. Similarly, the semiconductor diode lasers having some disadvantages also. It has poor coherence and the poor stability. The second disadvantage is that the output is usually from the 5 degree, that 5 degree to the 15 degree. That means the divergence of the beam is more as compared to the another type of the lasers. So we can say that the large beam divergence can be observed in a semiconductor type of the laser. It is difficult to control the mode pattern and the mode structure of the laser. So here the mode pattern and the mode structure of the laser can be difficult to control. The next disadvantage is that the temperature affects its output. We know that due to the variation in the semiconductor, the resistivity, due to the variation in the temperature of the any semiconductor material, there is change in the resistivity. So here the temperature affects on the semiconductor material. Its cooling requirement is considered to be a drawback in some cases. Due to that, if the temperature affects on the conductivity of the semiconductor material, so if we use some cooling system, now then the cooling requirement is considered to be a drawback in some applications. So remember, these are the disadvantages of the semiconductor diode. Now then, the semiconductor diode having the different applications, such as it is widely used in the fiber optic communications. Friends, we know that in a communication system, the fiber optic communications is very popular to transfer the signals, and so in a fiber optic communications, the laser diode having the very vital role. The second application is that it is used to heal and the wounds by the infrared radiation. So in the medical applications also, for healing the wounds, the semiconductor diodes are very useful. They are operated in the infrared region. The second medical application is that it is used as a painkiller also. The next application is that it is used in a laser printers and the CD writing and the reading. Nowadays, the laser printers are very popular, and in that laser printers, such a type of the semiconductor diode are used. The second important or the next important application is that we know that in the computer system, or in case of that the CD players, the writing and the reading purposes, the semiconductor diodes are very popular. So the friends, remember the different applications of the semiconductor diodes in a different place. Now then here in shortly we can see the characteristics of the semiconductor diode. Okay, the type, it is a solid state semiconductor laser. The active medium, a PN junction diode made from the single crystal of the gallium arsenide is used as the active medium. Then which type of the pumping method used? The direct conversion method is used for the pumping action. That means we are applying directly the electrical supply to the PN junction diode, and there is the direct conversion. So here the electrical system is used as a pumping method. The power output from this laser is in 1 milliwatt. Then the nature of the output. The nature of the output is a continuous wave, or it may be in a pulse. wave mode also. Now then, what is the wavelength of the output? The gallium arsenide laser gives the infrared radiation in the range of the wavelength 8300 to the 8500 angstrom unit. So the friends, remember, all these are the characteristics of the semiconductor diode laser. So friends, in this lecture we have seen in details about the working principle, the different elements of the semiconductor laser, the working, the construction and the working, the advantages, disadvantages and the application of the semiconductor laser. So remember all about the semiconductor type of the laser. Thank you.